So we already know a little bit about equilibrium systems. We know that they occur in a closed system rather than an open system. We know that the reactions, the chemistry we're talking about is reversible rather than irreversible. And we know that at equilibrium, the rate of the forward reaction and the backward reaction are equal. Okay. What happens though if we disturb that system? What happens if there is a change to that system and that impacts on that equilibrium state? How do we deal with that? Well, this is where this idea of Le Chatelier's principle comes in handy. Now, this principle basically states that for a system, a closed system at equilibrium, if it is subject to a change, the system will shift in a direction to partially oppose that change and re-establish equilibrium. Now, what does this actually mean? It means that if we do something like add more reactant or more product, or we take away some reactant or we take away a product, that is, we're changing the concentrations of these, the system will adapt to that. So for example, if I add more of a reactant, it means that we now have more reactant molecules that can interact with each other. And to partially oppose that change, the system will react in a forward direction. It will shift in a forward direction, which means that those reactant molecules will collide and interact and create product molecules. And so the system has opposed the change where the concentration of those reactants has increased by shifting in the forward direction to decrease that concentration. The same thing happens if we take away a product, for example. If we take away a product, the concentration of products is decreased. To partially oppose this change, the system is going to react in a forward direction to increase it and therefore re-establish equilibrium. The same thing applies for a number of other factors that can affect equilibrium. These include things like changing the pressure or volume of a gas system, changing the concentration in an aqueous system, and changing the temperature.